right, so for this section, we are going to start taking the derivative of a natural log. So you will find out in some of these problems, it is easier to apply log rules first, which is why I gave you the homework at the start of this chapter, so you could refresh your brain on log skills. But bottom line is the derivative of a natural log, okay, is the derivative of the argument, which is the stuff in parentheses. Okay, so the derivative of x is 1 over the argument itself. So you get 1 over x. Okay, so let's try another one. I've got the natural log of 8x. Okay, so the derivative of the argument, so what's the derivative of 8x? It's 8. Over the argument itself, what's the argument? It's 8x. Which means your constants reduce, and you're left with 1 over x. Well, why did that happen? So just to give you an example of log rules, if you've got multiplication on the inside, you can separate that out to 2 separate logarithms joined by addition on the outside. Multiplication on the inside, addition on the outside. The natural log of 8 is a number. And what's the derivative of any constant? It's 0. So again, sometimes it'll be easier to do log rules first and then differentiate. So here we go. That was actually, I just made this one up and it was the first problem. All right, so we have g of x equals the natural log of 2x plus 7. Okay, so how do I take the derivative of a natural log? Take the derivative of the argument, which is the stuff in parentheses. So the derivative of 2x plus 7 is 2 over the argument itself. Well, what's the argument? It's 2x plus 7. And you're done. You have now differentiated. Okay? So let's do it again. We have h of t equals 4 times the natural log of t to the 5th. Okay, so how do I take the derivative of a natural log? Take the derivative of the argument. So what's 4's job? 4 is coming along for the ride. Okay, so the derivative of the argument, so the derivative of t to the 5th is 5t to the 4th over the argument itself, which is t to the 5th. Well, when you reduce that, t to the 4th over t to the 5th reduces to 20 over t to the 4th, t to the 5th gives you a single t. So what the heck? What happened to all my t's? Remember, if you've got an exponent attached to your argument, drop it out front as a coefficient. So I could have done 20 times the natural log of t. So this is algebra. I haven't done calculus yet. And then what's the derivative? 20 comes along for the ride. And I've got the derivative of the argument, which is 1, over the argument itself, which is t. So I get the exact same answer. Sometimes you're going to want to do log rules first. So let's do another one. I have f of x equals the natural log of the square root of x plus 3, and that plus 3 is not under the radical. So I'm going to go ahead and rewrite that. Actually, I'm not. Yes, I am. All right, so I have the natural log of x to the 1/2 plus 3. So how do I take the derivative of a natural log? I take the derivative of the argument. So what's the derivative of x to the 1/2? It is 1/2 x to the negative 1/2 over the argument itself, which is x to the 1/2 plus 3. And you can clean that up. It is possible to clean that up, but I'm not going to. I'm just going to leave it like that because I can. All right. So I have f of x equals the natural log of 1 over 3x to the 9th. Okay? So I'm going to go ahead and use log rules and separate this thing out. So I'm still in algebra world. So if I've got division, then I use multiplication, or I use subtraction, sorry. So I've got the natural log of 1 minus the natural log of 3 minus the natural log of x to the 9th. So I've got 3 factors in here, and I gave each factor its own log. So I've got the natural log of 1 minus the natural log of 3 minus the natural log of x to the 9th. And then what can I do with this x to the 9th? I can drop him out front as a multiple. Okay, so now what do I have? I have, well, this by definition is 0, but its derivative is 0 anyway. So my derivative of the first term is 0. This is a number, so its derivative is 0. And this is differentiable. So I've got a negative 9 who's coming along for the ride. The derivative of the argument is 1 over the argument itself. Okay, so that is your answer. Negative 9 over x. Let's try another one. All right, so I have find the derivative of the function. My derivative is the natural log of 4x squared minus 3x plus 6. Okay, and I'm not really seeing much that would benefit me. I don't want to try and factor or whatever. How do I know? Because it's easy enough to take this derivative. Okay, so his derivative, instead of applying log rules, I might as well just dive in and take the derivative. So the derivative of a natural log is the derivative of the argument, which is 8x minus 3, over the argument itself. So just rewrite the argument. 4x squared minus 3x plus 6. And that's it. You're all done. All right, I have find the derivative of the function. So I've got f of x equals the natural log of x plus 2 over x minus 2. All right, so let's talk about this one. To take the derivative of a natural log, I take the derivative of the argument, which is going to use quotient rule, over the argument itself. So I'm going to end up with a heifer fraction. Or I can remember that if I've got a connection of division on the inside, I can rewrite it as subtraction, so minus on the outside. And now life just got a whole lot easier. So how do I take this derivative? The derivative of the argument is 1 over the argument itself is x plus 2 minus the derivative of the argument is 1 over the argument itself is x minus 2. So I didn't have to do quotient rule. I didn't have to do any of that mess just because I applied log rules up front. So that makes life a whole lot easier. Okay? All right, let's try this one. So f of x equals 5x squared times the natural log of 9x. Okay, so what do I have? I have product rule because I've got variables times variables. So how do I do product rule? First, so 5x squared times the derivative of the second. So the derivative of the second is the derivative of the argument over the argument itself, plus the second times the derivative of the first, which is 10x. So that reduces, and I'm left with a 1. So and this reduces, so you have a 5x plus a 10x times the natural log of 9x. Okay, so the 9's reduced, and that left me with a 1 over x. And then this x reduced with one of those x's. And so I have a 5x to the first plus 10x times the natural log of 9x. Okay. Now we have f of x equals 9 times the natural log of x over x to the 6th. So my bigger picture is I've got variables over variables. So I'm going to go ahead and use quotient rule. And it's going to be messy, but we know how to do this. So the bottom, which is x to the 6th, times the derivative of the top. So 9 is coming along for the ride. The derivative of the natural log is the derivative of the argument, which will be 1, over the argument itself, which is x. So this is a 9 over x. So bottom times derivative of the top minus the top times the derivative of the bottom, which is 6x to the 5th, all over the bottom squared. So x to the 6th times x to the 6th is x to the 12th. So if you want to clean this up a little bit, you could rewrite that as just x to the 5th times 9. Okay, you don't have to, but you can. All right, I'm going to find the derivative again. I know that's a surprise at this point. All right, so I've got the natural log of, and then my argument is x squared minus 7, but I'm under a square root. So if I need to take this derivative, I'm going to have to use power rule, and I'm going to have to use chain rule. Or I can remember that I can rewrite that as x squared minus 7 to the 1/2 power. And now look at this magic. I can drop my 1/2 out front. So I've got 1/2 natural log of x squared minus 7. And that process of differentiation is a whole lot easier than if we had just dove in this way. So the 1/2 is coming along for the ride. So I've got a 1 over a 2. So I take the derivative of the argument. So the derivative of x squared minus 7 is 2x over the argument itself, which is x squared minus 7. So your 2's reduce, and you're left with x over x squared minus 7. Sorry. All right. I'm choking to death, but everything's good. I have f of x equals e to the x times the natural log of the square root of x plus 4. Okay, so using what I did before, I'm going to go ahead and rewrite this radical as a power to the 1/2, which means I'm going to drop my 1/2 out front. So what this says is 1/2 e to the x times the natural log of x plus 4. I have not done calculus yet. Okay, so what do I know how to do? I've got variables times variables. So I'm going to go ahead and use product rule. So I have the first, which is 1/2 e to the x, times the derivative of the second. So the derivative of a natural log is the derivative of the argument over the argument itself. So I've got first times derivative of the second plus the second, which is the natural log of x plus 4, times the derivative of the first. So 1/2 is coming along for the ride, and the derivative of e to the x is e to the x. So he's 1/2 e to the x. So that whole thing is your derivative. You could write this e to the x in your numerator and put your 2 in your denominator with the x plus 4 if you wanted to, or you can just leave it alone. All right, so last one. I have, what do I have? G of t equals t squared times the natural log of e to the 2t plus 8. And I want to take this derivative. So my bigger picture is I got variables times variables. There's really no way for me to simplify this down algebraically, so I'm stuck. So I'm going to have to use product rule. So that says first times the derivative of the second. So the derivative of the second is the derivative of the argument. Well, how do I take the derivative of e to the 2x? I'm going to write what's sitting there times the derivative of the exponent all over the argument itself. So over e to the 2t plus 8. So I've got the first times the derivative of the second plus the second e to the 2t plus 8 times the derivative of the first. And that's 2t. Okay, so it's kind of ugly, but remember that is the shortcut. All right, so you are now ready for your Chapter 5 test.